Are we live?
Yeah, we are live. So let's switch over here. All right. Hello, everyone, and welcome to the ClusterDuck Protocol stream.
All
I'm
right.
Nick, and I'm joined today with Timo,
Hi, everyone.
Terracor, and Zach. Um, and so last week we worked on. Actually, maybe I'll take a step back. This stream, we will be doing a pair programming session where we work on issues within CDP. Um, CDP stands for ClusterDuck Protocol. It is an open source firmware for mesh networking, primarily focused on disaster relief. So we'll be working over the next hour on an issue today. So last week we finished working on the double duck, where we were able to uh, upload two profiles onto a single duck and be able to transform that duck from a mama to a detector. You can check that out with all of our streams are recorded. You can check out on our YouTube channel, Project Owl. For any more information, you can check out our website, projectowl.com, as well as our GitHub. Um, Now, to get into what we're doing today, we are working on a new issue, and we're working on when a message is received to be able to send a second message to send additional information. So, for example, right now we're doing a lot of testing to help us understand how does the network work. So, a lot of telemetry data, whether battery life, but we also want to get additional data such as RSSI and SNR. Now, what that means is RSSI is the signal strength between when a packet is received from another device. SNR, it gives us an idea of the noise of radios, what kind of the radio environment is. So if we are, let's say, losing a lot of packets because we're trying to send messages over the air, and we're losing them, it could be because there's a high there's a lot of noise, which could make the packets more corrupt. So we have a little sophisticated list right here for what we want to do. So when the duck receives a packet with telemetry data, we want to relay that packet as we would normally would. However, we want to add another functionality where we send a new packet that is that with the RSSI and SNR data of that packet was received. Now, this is important because it allows us to know how good how good of a spot our each duck is. So if they have a really high RSSI, that means that the signal strength is the signal strength is really low. So this will help us get a really good idea about the topology of the network. But there are also some other things here. We only want to send on telemetry packets. What this means is that if we were just to normally send a packet after receiving a packet, we would have an infinite number of packets being sent, looping, and we would end up with something we call duck DOS, which is basically means that so many packets are being sent in the network that now no information is able to be passed anymore. Kind of like what you would expect from a regular DDoS attack. Now, also, we want this to be able to be handled in the application layer. So what that means is that we want this feature to be accessible on the INO side. So we don't want to have to bake too much of this feature into the CDP library. We want this to be something that is mostly done on the application layer. So I think that is all for the introduction, and we're going to dive right in. Anything I missed, guys?
No, I think the important thing here as well is we want to get this information to later do some network analytics and figure out how the network is operating. Instead of just recording this stuff one time, we want to actually couple the data we're getting to this message. So every message is special, and we want to know for the telemetry data packet on how it's performing. Because if we would just set up a duck and send RSSI or other values once, that doesn't mean that will stay the same over the hours or days the network is operating. So what we're going to do is we're going to actually, once the data is into our database or into any local database, we need to actually couple or put these two together to actually see how what message came in and how that message through the network, meaning what kind of RSSI value or other metrics we can collect for a specific message compared to a specific duck. I think that's kind of like the cool thing about this.
And that's kind of part of where we wanted to get a more granular view of how the network is running. So we could have done is just collect the RSSI data over time and for whatever devices that's nearest to it, and then just send an average. But for the kind of data that we are looking for, we want to find a real time what kind of RSSI values we're getting and how it maybe changes over time as well. So that's why we are taking this approach to it. And that might change over the course of the stream. This is, as I mentioned earlier, this is a live coding session. And as we go along, we might have to change things as we go along, as we discover what works and what doesn't work. But that's all part of the journey. So I hope everyone's strapped in and ready to go, because we're going to dive into some CDP. So where we would like to start is in Duck Radio, I believe. So Duck Radio is what handles all of our radio communication stuffs, like receiving packets, sending, relaying. So a lot of the radio logic is here. So if we're in the situation where we have a duck, we have duck A has sent telemetry data. Now we're in duck B, and it is reading the received data. Now, we're kind of also doing a little bit of a 2-for-1 here, is that currently when you receive a packet, and then you try and transmit that said packet, and there's an error, I think we lose the packet. But we don't. But at the end of the day, we don't save this packet data. Once everything is complete, everything is flushed out. So what we want to do is we want to create a way where we're able to save packets. This is also can be helpful later down the line for if we want to do verification that a packet was sent. So, all right, so let's get started. So if we're going to do saving a packet data, we're probably
what's the first step we do? So when you get a message into your duck, you want it to save that data instead of just relaying it. You actually want to save it so we can access it from somewhere else, right?
Yes. So I think maybe I just help start visualizing what we want to do here. Let's just start with the method that we want to do. So save packet data, right? So at this point in this method here, we already know that the data is good. So we've already checked everything. The packet, it looks good. We've done the CRC, which is basically check to make sure that the data is all there and it's not corrupt. That we can continue moving forward. So what we want to send here is we want to send the packet bytes. Yeah, is that the... Yes, that's what we have here. All right, so packet bytes. All right. Now, why don't we put right here? We'll have void.
So for anyone who doesn't know, PacketBytes is whatever came from the receive module on the LoRa. That's passed into PacketBytes, and that's what we're also passing into the save packet data. So this is the one thing we are not able to do inside of our application layer, because we are not able to get any data into the application, because what we do is we receive it, we check it, and just send it. And it's never saved where we can access it. So that's what Nick is doing now. He is making a method where you can save the packet bytes, which is whatever came in. You can access it from somewhere else, and then you're able to do something with it.
Did I initialize this wrong? Or maybe is it just complaining that... Here, let's just add this to our header file. Let's put this in with the... where do we have read received data? Alright. Alright, that looks good. What? Back. Oh, this is not spelling it correctly. That's why.
Yeah.
That
That's,
would.
The vector.
That. Yeah, that would help if I spelled things correctly. All right, so we have our method here. Now, what do we want to do with it? So we want to put this into an object. So we have something very convenient called CDP packet. And we'll call this packet. And we'll put packet bytes into this. So what? Let's see what's not like about this. Let's double check here. CD packet. Oh, it wants the buffer. Oh, it does not. Does it not take it? Wait, am I using this properly? Let's see, how are we using this in MamaDuck? We use this here. Oh, that would make sense. Alright, so what I'm doing here, duck radio, is packet equals, I'm just not doing my stuff right. Packet bytes. There we go. Please like me. Alloc here, byte. Let's see.
going to open up my code so I can actually look things up for you when I'm looking at your stream.
Packet data. It's because we have a pointer here, or actually, well, it's because of this right here. Just because I changed that. We don't want to send a pointer. We want to send the actual. All right. Okay. So
You just created like an object, a new object called packet, and that has the format CDP packet. So all CDP packet is what Nick had opened just now. That's like our form, what the packet should be.
Yeah. So now how do I... Oh, man. Working with pointers. So... So we have a pointer to... I forget how to do this properly. Let's see. No, that's... How do I get what this is pointing to and change it into... this is a simple way to do this.
Do we do something with PacketBytes when we pass it in?
What?
So when we pass in PacketBytes, do we change whatever the structure of it is?
No. So it's not so much changing this. We'll change the structure. Right now, it's just sending the right type of data. So so what is going on right here? So this is a pointer to a vector, byte vector, but I want to send the vector itself.
Got it.
So, and I am blanking out on how I can do that simply. All right, so let's look at, so here, let's go to the MamaDuck CPP, because we do something similar here. Okay, so how do we send this? This is in the setup. We handle duck data on receive duck data. Let's see. Now, what is the? Oh, is this in duck? Let's see. Man, where is the on receive? Oh, here. Alright, it's getting it from a callback. Let's see. What was that? Was how to get vector let's see. To the raw data. Let's see. And there's the compiler. Oh, data. Okay. So, it's very simply, I've done this before. I'll go back here.
Yeah, I was relying on TerraCore to know the answer, but you just said quiet.
So, dot data. Man. That should do it, right?
Okay, makes sense. We're just getting the data inside of the vector.
Yeah, but that's not doing it. Wait a minute. Let's see. Vector data. But
Yeah, we do that before. We do a lot of get buffer.data or buffer.data.
I think it's fine. I think it's not updating. I think it's fine.
Yeah.
That should work. I had this before where it says the lint is saying linter is saying like you can't do this, and then I reload it, and it's like this is totally fine, but I don't know. We'll see.
Do we have to pass in the size of packet bytes?
No, we don't need to pass in the size. So, but here in CDP packet, so what we have here is what's really nice about this is that with this constructor we build, or with this we build. We have the buffer length. We have all the information here that we would need to if we needed to resend this. So I think what we want to do here is add some more items. So I think we'll put our RSSI. So we put int RSSI, and then we want to add here SNR, because this is the data that we wanted to be able to get later, as it is valuable. Well, we also could add frequency error as well. Yeah.
Do you want this data to be part of the payload or part of the packet structure? Like part of the data inside of the...
So what we're going... says for what we're trying to do, so we're trying to link the data. So, actually that brings up a really good point. You should check out, we have documentation on how we handle all of our messaging. So what does different things mean, and what does how we do it, and also why we chose these different designs. And what you even have here, this is what originally messages looked like in the past. But so definitely check that out for more documentation. Read our wiki. We have a lot of information. So definitely check that out. We'll include the links in the recording. But so what we're doing here is we're saving the packet, and we're going to, but we want to access the packet if we want to, let's say, resend it. or if we wanted to check later, the message ID and say, hey, did the what get like a message receipt? So with we would have to cross reference with a message ID, and if we didn't get it back within a certain amount of time, we would still need to be able to send it. And so that's what this object will save all the bytes for what we use to make up a packet. We're not going to use LoRa packet because it's a lot of information is missing in this structure. So we're going to use the CDP packet because it has all of the different stuff that we would need to rebuild the packet. So we have C error and all right. So all right. So what we want to add to this packet RSSI here. Now we can do this. I want to do LoRa and packet dot what was the other ones? SNR. Let's see. Oh, it only does it when it gets initialized. Alright, we can fix this. But this is essentially what we want to do.
Do we have to adjust like the packet length since we're adding our
No,
size?
so these are just attributes of the CDP object. So let me go here. Okay, so this is, we don't want this here. Or wait, yeah, we can put this here.
That makes sense. Otherwise, we forced it to be part of the packet, right?
Yeah. Yeah, and so here, yeah, so we never declared it, and also we never anyways set it in when we're building the object. So yeah, that makes sense.
So if you look at the schema above, where would this data, in this file, just go above a bit, where would the data live?
Where?
And so if you go to the structure with the head and the bytes where we just were, the RSSI, where in this diagram maybe is interesting to explain where would the data RSSI, SNR, and frequency error, where would that go into?
Well, they're attributes of the object, or is how I would describe it. So we just created a new object here. Let's see. Go back here. So we were creating a new object, right? And then we're adding some attributes to it. So inside here, it has all the packet data, which we're going to need because we want to link it to the message ID, right?
Yeah.
So, and then these are the additional information that we want to add. And so when we grab this packet, right, from somewhere else and want to do a bunch of stuff to it, we'll also be able to grab all this as well.
And you're getting the RSSI from that packet in this scenario?
Yes. And so this is from the last packet received. So we're going to be doing, so save the packet data here.
And then my question was, will you show you're adding it, but it will be part of the payload? So the actual bytes we're sending as part of our...
So we're sending a completely new message, right?
Yeah.
So we're going to be building a completely new packet, and then we're going to add this to that payload. But it's not adding. We're not adding to the payload that for
correct.
packet.
Mm-hmm.
But in the where we have our diagram, that's like this is reserved for the head, this is reserved for duck type, this is reserved for all that stuff. Are we going to rebuild that structure as well, specifically for this packet?
Yes, we're rebuilding everything because it's a completely new packet. But we're just going to also make sure that it when we do the data analytics, it links back to this packet.
Got it. So it will have a head in a way that says, this is the MUID of the previous one that it's links to.
Mm-hmm.
Okay.
And then we'll probably have to have a different topic for it, right?
Yeah. Well.
For this one, we'll probably create another topic. I think. So I think we should probably, anyways, create a telemetry topic, or maybe we use the health topic. I'm not exactly sure. Yeah. But we can discuss it.
Yeah. Otherwise, we wouldn't know how to only do this when telemetry data comes in.
Mm-hmm.
So we'll have to do it by topic.
All right. Sorry for the sound in the back.
You all right, Nick?
It's an emergency.
You in danger?
Here. This dog is just not waking up. Good girl. All right. So we have that. Now we do have a bit of an issue here. We are right now recreating this object over and over and over again, which could lead to a memory leak. So, let's see.
Can we create another function that create the packet, and then after it sends a message, empty out the packet, swap it or something?
So, what we need to do is we need to delete this. So, what we would need is probably we would have something like this. I think what we can do, delete. And what we need to do is we need to add this to duckradio.h. And we need to add in here CDP packet. Let's see, that good? All right, cool. To complete object type. Must be a pointer. And just do that. Nope.
Isn't that like what you mentioned before? How it's actually not deleting it? Well, if it's a different size, it might not delete the whole thing.
That was for... Yeah, but that's for if we're using new, I think.
Do you want to check first if packet has something in it before you can delete it?
Well, I mean, we could store it. We could store it into like an object vector, right? Let's say we wanted to store multiple messages to it. So what we could do instead is we could still have and have another process that cleans it up. So what I'm talking about is what we could do here is instead of having this here, we could have a so we have like what saved packets, and then we have you know what I mean? So what we could do is you could just, add to this.
So you want to
So
store
are we?
multiple packets? You want to store multiple packets?
Yeah.
So that means like if we send like 10 messages, it'll have all those 10 packets in it.
Yeah. Which I don't know if we could probably put a limit on this.
Because we in the scenario where we only do this whenever we get a message in, why would you want to save it, the 10? Because it will only do it. The message comes in, it will trigger the send, and then it has to it could just delete it, right?
Mm-hmm. Well, also, that doesn't really solve the issue, right? Because even if it won't. I'm not sure if it'll explicitly. Let's see.
Can we do something where if the message was sent successfully, we can write nothing to it?
Mm-hmm.
We can set it to nothing.
So let's see. Well, so you can overwrite. So remember, if you have a situation where you have your first entry is 10 bytes long, and then you try to overwrite it, you don't necessarily free up that data or that memory anymore. We have to explicitly free it up, because I depending on how we do it, we might not. So let's say we free it up so that we can use the first, because the next one is only 5 bytes long. The tail end 5 bytes might be just hanging around, and that memory does not get freed up. So, let's see how to delete.
So we should find like an empty method instead of writing something. Overwrite it. If we should tell it empty.
See how to delete.
Zach also commented about saving it into a SD card.
Yeah.
So would that be the part where we save into SD card?
Different, because what we're doing now is we're adding something to that object, so we would have to create another method that's just saving the buffer, which whatever is coming in. But in the scenario of an SD card, we can probably just write straight when it comes into the SD card as well. Now we're trying to get the packet, add something to it, and resend whatever we get. So we have to access the object again. I think for the SD card, we can just, whenever it comes in, write directly to the SD card, which might be a little bit easier, I guess. Or we will run into the same problem.
Yeah. So here, this is what I was looking before, is how to delete a structure. And so I've seen this around where using the smart pointer, which sounds pretty cool. I've never used it before. Control by swarm automatically destroyed. Unless its owner has local variable. Okay, so but this is so smart pointer only works for like a local variable. All right, so if we use a smart pointer, it would work well in this situation here. But because this is we're doing a local instance, but let's see. So how to. So I don't know. Using a global variable is also not the best way. Well, let's just go down this rabbit hole and see where we end up. Let's see how to overwrite object C++. Here, destructor. Let's see. Yeah, I'm just trying to figure out how to do this without creating another bug.
Yeah, because
Bugs are inevitable.
yeah, but we could just go the route where for now we just overwrite it and then look into the fact how to empty it later, but really document that. Figure out how to empty the object whenever we send it.
Okay. All right. Well, I guess we always can go back and fix the bugs. That's what we did last time too.
I will make a note of it.
Can we for loop it?
Huh?
Can we like for loop do the pack and delete everything?
Well, part of it is you just don't want to, because you have to. Like you could technically go in and do a free function, I think on every part, but it's definitely not the right way to do it. You could just brute force free it, but there's definitely a right way to do this. And so I think what we'll do right now is we'll just do a packet and have a packet. All right, so now we have our packet that has all the data that we want in it. Right? So now what we need to do is we need to be able to grab this packet. So we're going to need a getter. Where do we keep our gets here? Do we have any?
It's in the header file, like the H file.
I'm just trying to find a spot where I want to put this method. I guess we might as well just put it right here. And what we have here is I'll be returning CP packet, and that will be called get Last packet. And we have return. Okay. And we want to call this duck. Oh, duck radio. Get last packet. And we'll add this guy to our header file. Does not need these things. All right. All right. Is everyone happy now? This guy's still not happy.
Yeah, that's
Well,
an interesting.
I'm pretty sure this is correct, but we'll see when we compile. We'll fix it. But this is a general idea, anyways, of what we want, what we're trying to do. Okay, so now we need to access this packet in the INO. So why don't we create another custom Mama example. New folder, we're going to call it custom Mama Telemetry. Let's wait, I can't spell today. Telemetry. Alright, and then we're going to add another file here. Custom Mama Telemetry.ino. Alright. So what we're going to do here is we're actually going to copy, I think, the MamaDuck. And we're going to put this in here. Now, now we do have a function. Say duck dot on. Oh, maybe we don't have this for Mama, because in the Papa we have a really nice callback. Let's see, on receive duck data.
Yeah, it's part of the PacketBytes setup.
Yeah, actually, could we just do that with the Mama?
Do you think we can add it to the Mama example? To the Mama method?
I mean, we can try. Yeah, I'm not 100% sure on it because I didn't write that part. So we can just try and see if we look at PacketBytes.h. Oh, let's put you guys back up on here. Look at PacketBytes. Where is PacketBytes? It's down here. Here we go. So we add these callbacks to, or does the MamaDuck use it too? I'm not sure. Don't have it in here, but if we add these in here, because then actually we could get around using the CDP packet stuff that we were using before. So
Yeah, we can always talk about if we want to implement this here, but I feel like for it wouldn't matter because anything we want to do with the Mama that's adding packets or reading the packets in the application layer, we need those two methods to figure out what came in and what's going out.
So I'm going to do this. Was on receive. I thought I added that. Let H. Oh, well, yeah. We're gonna need this.
Inside of the CPP as well.
Let's copy the documentation on this. Yeah, it looks fine. Well, let's see. Receive data callback. Oh yeah, that's right. We have this down here. And let's see. So, well, one of the issues here is for this callback is that we're going to get the data before we hit this one, right? It would be better if we were able to use this callback after we sent it. Because also this would make it a lot easier if we can get this callback to work. This would make it a lot easier because we can we don't need to keep checking. This would just only be run when there is a packet.
So what's the order of running right now? You said we handle the packet and then
so this callback. Actually, I'm not sure. Well, okay, we can test it and see. Now if we go to here, we can have let's see, void RX and then but also we want this is this will take a what is it? A oh, I think I lost him.
Yeah, we lost Timo.
Okay. I don't know. He accidentally touched his wires or something.
Yeah.
Hey, Timo.
Keeps happening where the computer keeps doing weird stuff. Hopefully you can see me guys again.
All right. So
Cool. Back.
all right. So now we receive the packet data. Oh yeah, and this is where we would be able to put it into We could put CDP packet equals CDP packet buffer. Might as well just put this whole stuff in. It doesn't take that long. Yeah. And like we would just put here, have like a, we would do like a check on it, but all right. Oh, we can do that later. So let's see. So I have a duck on me here where we could try this.
Yeah, I'm curious to see this because you're not going too quick, but I lost you in the way how we structure this.
Oh, okay. So what? So this part right here.
Yeah. So what? You trigger the callback. So you will receive the message, and then it will trigger the callback, right?
Yes.
And then we'll run. Then we'll create the new packet, and we still have to build in sending a new packet, right?
So, so we have a callback that when we receive data, right, it's going to run this function, and it's going to put this in here. But I'm not 100% sure when this callback runs. So, because this callback, so we got our radio events here. So, because this could run when the receive is done. So what that means when it's received the packet, but that doesn't mean it has done all the processing on it, because that's what we do in the handle packet, right? Let's see if we go to the MamaDuck CPP. I guess we don't have it open. So many tabs. All right.
Yeah.
So if we go to handle receive packet, so you see here in handle the receive packet, we do a bunch of different stuff, right? So, but actually maybe it happens after it because, yeah, read receive data. Actually, let me look at the. Where's MamaDuck to H here? Call when invoked to the packet needs to be relayed. Okay. So after it's done, the check on the check on it. So what check I'm talking about is it checks the path, right? So we have to check the path to see if check the path if it hasn't been seen before. So whenever a packet is relayed, the duck will have a digital signature on the packet itself, and as long as that digital signature is the duck's its own digital signature is not on there, then you can then it will relay the message. So after it has done that check, it will be done.
Got it. Okay. I'm curious to see this work.
Yeah, so let's see. Okay. All right, we got an error. Oh, it didn't like this.
There's still something wrong with actual sending
Which is
the
a
data.
binary tar. Why is it unsigned char? Should be. Maybe meant to use that. All right, wait. So yes, we're getting an error for that thing that was just not lining up. Why is it saying that I could do this? No. But wait, why is it saying Docker seed data unsigned char? But it should be a pointer type. So you see here, so the error I'm getting. Rest remember data in PacketByte was not a pointer type. What is it then?
Yeah, I wasn't able to see the last part because your stream is overlaying the error message.
Oh, here. I bring it up a bit. Can you see it now?
Give me a second.
So
Yeah, okay. Maybe you want to use blah blah blah. Okay, that didn't work. Unsigned jar. Interesting.
Yeah, actually, you see, we do this right here.
You just pass in the same thing.
Well, it's just the data. So this also might be wrong still. Okay, no, so constructor exists to convert from byte. I mean, like, what do we need to do? Vector, byte, for, and then we have for insert for that and then okay, that doesn't. I mean, I don't know. This just does not seem right. I have to go through all this. This is just not. How do we get? All right, you know what? This is not important right now. We're trying it a different way, anyways. Yeah, we're trying a different way, so let's see how this goes.
always the best moments. See if it will compile.
Yeah, it's also just worse that it takes forever to compile.
Yeah, this stream I've just been watching you and trying to follow you because it's a little bit out of the stuff I mostly work on. I'm more in the web portal stuff and all those things. So last week was perfect, but
Sometimes you just need a soundboard, right, to
exactly.
walk through things. It's also weird for me. Still getting used to working on a stream.
Yeah, the struct was new for me. Creating like this struct and using the struct.
Oh, well, we ended up not using the struct. We used the class, but yeah. We were talking a bit before about this struct, right?
Yeah.
And also handling memory. This also is like memory allocation, and man, I had a lot of issues with memory leaks. 0 provided. Duck packet. What's the issue here? No matching function to call to CDP packet. Let's see. What does that? Let's see. Duck radio. I mean, we're already including it from. I don't think this is it, but because there should be, because we already include it from duck packet.
Maybe the linking doesn't go as expected.
Maybe. Not sure. We had a similar issue before where with vector it should be it should be picked up, but when it came to the compiler it just was not. So all we need to do is add an extra include, but yeah, so I guess this will be the last one we try, and then we'll close it off for the stream for today. And then we'll continue this next week. So to close it out, so I made some progress here, trying out some different stuff. Like I said before, this is a bit of we're taking you through the journey of trying to figure stuff out. And while we navigate and try a bunch of different stuff. Still a bunch of errors, but work on it. We'll continue to post some more information, as well as working on a stream schedule. We'll be continuing to stream Thursdays from 11 to 12 Eastern time. Feel free to drop in and ask any questions or comment. It's an open discussion during these streams, so if you know how or have suggestions on how maybe we could do things differently, definitely reach out to us and let let us know. We're always learning. And I think that's it. Any closing remarks, guys?
No, I think we can do some research the next coming days to get that resolved. But I think you did an excellent job of working on this, and Tarek and I enjoyed watching you. So yeah,
Yeah, I came in thinking that I'll help out, but I learned a lot more than that helped out with.
Well, hey, if someone learns something, then that's good. So, yeah, it's all just a learning experience, and we'll be getting better at it as we go. So, yeah, awesome. All right, thanks everybody, and
Thank you,
see you next week.